There's 2 other places throughout the world that do this unmanned robotic spacecraft tracking for the Jet Propulsion Laboratory out of Pasadena, and that's in Madrid, Spain, and Canberra, Australia. And the 3 complexes are 120 degrees apart. That way, JPL has continual tracking coverage of the unmanned robotic spacecraft in deep space that we track. So we track 29 spacecraft that are beyond the moon, and we track them using radio waves or radio frequencies with our large antennas. Currently, we have 6 antennas for spacecraft tracking. 5 are 34 meters in diameter, and then 1 70-meter dish. So to start off, this is just a map to show you, in case you don't know where Spain and Australia are. Australia has 1 spacecraft that is different than any of the rest of the spacecrafts, because it's in the southern hemisphere, so they're the only ones that can see it. Where all the rest of the spacecraft that we track, we all take turns tracking as the Earth rotates around. And that's Voyager 2, so it's one of the furthest man-made objects in space. The only thing that's further than it is Voyager 1. These are our antennas. So like I said, Goldstone, we have 6 antennas. In Madrid, they have 4 antennas, and in Canberra, they have 3 antennas. Here at Goldstone, we're the oldest of the complexes, so we started tracking in December of 1958, and our very first antenna was named the Pioneer Antenna after the Pioneer mission. And Goldstone ended up being quite a bit larger than the other complexes. We're 52 square miles, and we're the shape of California inside of California, so somebody had a sense of humor. They were drawing our boundary map. And Goldstone is named after the old gold mining town that was here. So California Gold Rush, they're looking for gold all over the place. We had a gold mining town out here, and the miners, when they abandoned the site of Goldstone, left behind our mascot, our furry friends, the burros. They are completely wild. At last count, we had about 100 of them. It's kind of hard to count them because they're wild and they don't tag them or anything like that, so we really have no idea how many there are. But they are all over the road, so we just have to be careful when we're driving because they're not as smart as the cars. Let's see what else. So we have 11 antennas total, but 6 are for spacecraft tracking. The rest of the antennas are decommissioned antennas because they are older style and the maintenance just got to be too much on them, so they decommissioned them. We have 1 research and development antenna, and we have 1 antenna that is for a school program called the Gavirt program. It's the Goldstone Apple Valley Radio Telescope, and it's a K-12 program that was started here in the high desert at the Lewis Center. It's a charter school, and they let kids run the antenna via the internet, look at objects in space, work with specific missions like the Juno project on its way out to Jupiter, and then they record the data and then ultimately get it validated by the scientists and researchers at the Jet Propulsion Laboratory. So what this shows you is that what we are currently tracking at Goldstone is the Mars Odyssey spacecraft. And if you notice, that last screen will change as I go through these views. This is showing you where Mars Odyssey is in its orbit around Mars, and its closest neighbor, which is the Curiosity rover. And we use the orbiters at Mars to talk to the rovers on the surface, just because it's pretty much easier with the Earth rotating around and Mars rotating around. Right now, Mars's round-trip light time is 40 minutes, so that's how long we have to wait to get the signal back. And it shows you the azimuth and elevation of the antenna and also the range. And then if we just go through that last screen, it'll show you what Mars Odyssey looks like, what Earth looks like from that vantage point, and then a close-up. And we're actually also tracking more Mars spacecraft. We're tracking Opportunity, which is the 2003 Mars Exploration Rover, and Mars Reconnaissance Orbiter. So this is going to, the last screen will kind of go through and show you where they are, where the rover is on the planet, and then where the orbiter is in the sky. Kind of makes it more confusing when you have to talk about 2 spacecraft at once. This is what Earth looks like from Mars Reconnaissance Orbiter's orbit. That's Mars Reconnaissance Orbiter. There, it'll show you that we have all kinds of things at Mars. We have Mars Reconnaissance Orbiter, Curiosity, Mars Express, which is a European Space Agency mission. Oh, and then it just changed. So, there it is, Mars Express, which is at the North Pole. And then we're also tracking the Messenger spacecraft at Mercury. Mercury's round-trip light time is 10 minutes. So that's kind of cool. This is what the azimuth and elevation is, and this is what the spacecraft looks like. So kind of cool. Also in Madrid, they're talking to Juno. It's on its way out to Jupiter. That's what the spacecraft looks like. Kepler, which is a telescope. And New Horizons is working at Australia. New Horizons is on its way out to Pluto and the Kuiper Belt. It'll get there in 2 more years. Yes?
Is that the shows a range of 3.8 billion kilometers? So is that what the distance is from
That's
Earth?
the distance, right? The distance away from Earth. So it takes 7 hours and 10 minutes approximately to talk to the New Horizons spacecraft.
The system controls from that part?
Well, if you think that's
away?
if you think that's impressive, then the Voyager 2 spacecraft, which I said was one of the furthest man-made objects in space, is 28 hours round-trip flight time and 15 billion kilometers away. And like I said, Voyager 1 is 33 hours round-trip flight time, and that's because they're the furthest man-made objects in space. They were launched in 1977 and 78. Yeah, quite old.
They just leave the solar system or something?
Not yet. They are on their journey to interstellar space. They're at the last bubble before they reach interstellar space. Yeah. So that's kind of cool. Do you guys have any questions? Kind of threw a lot of information all at once. It's kind of confusing. No? Okay, we're going to go outside.